will be discussing about rectilinear propagation of light and what is the connection of rectilinear propagation of light with respect to the ray of light which propagates in different mediums. Okay, so how the ray of light propagates in a different medium and how it is affecting and why rectilinear propagation is a connecting part, what is the relation between them. Okay, so we'll be discussing further. So you have seen this picture. Okay, this picture shows a door wherein the ray of light comes and it is divided into, you can see certain strips. Okay, and in the second case wherein you see a lady looking at a mirror and her reflection you're getting on the mirror. Now a child also does the same. He looks at a mirror and he gets his own reflection. Once you put a pencil in a glass, and see that the image is bent. The pencil acts like it is bent, but when you pull out the pencil, it is as like before itself. Again, when you put it in the water, it acts like bent. Why does this happen? We will be discussing about that. Okay, and you see a picture wherein a man is in a pond, he's on a boat and he's trying to fish. So where should he put his bow or the arrow? So where should he put his arrow? He's trying to pierce. So there are two images in front of him. There are no we will be discussing it further. There is no different two images. It is one image only. It is one is virtual and one is real. So you guys can figure it out in your minds, and I'll be discussing about this is IGCSE Physics for grade 9th and 10th, and we will be primarily discussing today what is refraction of light, what is reflection of light, and what is diffraction of light. And one more picture you can see on the background wherein a CD is radiating rainbow color. Okay, so why does this happen? These are all examples and we will be discussing this in detail. Okay, so put on your curiosity caps and we will be moving ahead, and we will be discussing this one by one. Why this happens, what is refraction of light, what is reflection of light, and what is diffraction of light. Hey there, welcome back. Okay, so we will be discussing firstly what is diffraction. So I'll take the same picture what you had seen earlier wherein a ray of light is coming from the door. Okay, so door and the between the door you can see there is a small opening and the light rays are coming inside. It is splitting into number of strips. Okay, what exactly are these strips? I'll just elaborate more on that. Okay, so you see the image below the picture itself. Okay, wherein plane wave fronts, a single line is represented as a wave. When you see a wave from the top angle, when you see it is represented in form of parallel lines, and when it comes in between two slits are blockages which prevents the light to flow pass through the slits. So once there is an obstruction, you can see there is a gap between these two obstruction. Okay, there is a purple color slit. Between the slit there is a small opening. I have zoomed into this picture more times, that is why the slit opening is showing you it is very large, but in fact the slit is the size of a pinhole. Okay, so pinhole, when you put a hole on a cardboard with a pin, small pin, safety pin, that is the size of the slit. Okay, so this slit we have magnified it maybe 1000 2000 times for you to understand it better. Okay, between the slits, when the ray of light passes, the waves are bent. Why does this happen? This is the question, and the answer is diffraction. You can see in green color, when the parallel waves are there, when they hit the slit which is represented in yellow, there is a small opening. From that point source you can see the waves are emitting spherical, and you can see spherical, not spherical, semi-spheres. You can see it is moving, it is oscillating ahead. Just stop above it, you can see a bulb. Okay, a bulb is emitting a light. This bulb should be a monochromatic bulb. What is a monochromatic bulb? I'll tell you. Okay, a normal light consists of many wavelengths. So a monochromatic ray of light will be consisting of one wavelength. So we will be taking this monochromatic ray of light and passing it through the slit which is represented in blue. Okay, so the slit will obstruct the light to pass from the opening. You can see there is a small opening, and this opening you can see plane wave fronts are passing through this opening, and once through this opening when they pass, and they come near the red color slit, you can see red represented in red. Okay, there is a small, you can see slit, and there is a gap between these two red color slits. So this will block the parallel wave fronts to pass through the slit, but the small opening which is there in between these two slits will allow the ray to pass. So this is a small point source. I told you earlier, this slit difference is the size of a small pinhole. Okay, so the light sneaks into the opening of the gap from the slits, and it moves further. When it moves further, it is represented in the form of semi-spheres. You can see semi-spherical circles, you can see. So this is a form of diffraction. In simple terms, you can see below light diffractions through a cloud. You can see the picture. Light diffracts through a cloud, and the sun rays are passing through the cloud. This is a beautiful example of diffraction of sunlight. Now we will be discussing more on the second part, what is reflection. We had seen a image, you can see below, a lady looking at a mirror and she is seeing her own image in the mirror. Okay, this is an excellent example of a reflecting surface. So mirror is a reflecting surface. You can see above this picture there is a kid looking at a mirror and he's seeing his face in the mirror. Okay, so the light rays passes, hits the surface and reflects back the reflected ray. Okay, so in physics we say incident ray, which is incident, okay, which is coming, this is from the source, and there is a imaginary 90-degree normal which is 90 degree, okay, perpendicular, 90 degree in the sense it is perpendicular to the surface, and whichever angle incident ray and normal is making, the same angle normal and the reflected ray would make. Okay, that is angle of incidence is equal to angle of refraction. If angle of incidence is 30 degree angle of reflection should also be 30 degree itself. Okay, because if you see, if uh, the angle which incident ray and normal makes r, it is represented as suppose we say I, angle I, and the normal and the reflected ray, if it makes an angle called r, so angle I should be equal to angle r, that is angle of incidence is equal to the angle of reflection. You can see on the top there is an image wherein white light, which consists of many wavelengths, okay, hits a green surface. The surface is green in color, and when the light hits the surface, it emits which color? Green color. That is why it is coming to our eyes in the form of color green. Okay, that is why our brain records the color as green. Okay, right next to that picture there is an image, okay, which shows that incident ray when it falls on a mirror, okay, and it the incident ray and the refracted ray, if we represented incident ray and the normal as angle I, as I told earlier, and from the normal and the reflected ray, if we consider it as angle r, so angle I should be equal to angle r. Okay, so this is a brief about what we call reflection. Okay, now we'll move ahead. This is a cool experiment what we can do. Okay, this is for an activity. Okay, two arrows pointing towards the right hand side. Okay, two arrows when they are pointing towards the right hand side is brought behind a glass full of water. When it is brought exactly behind the water, and you stand in front of the water and see the glass wherein water is filled, and behind the arrows where it was turning to the right hand side. Now what is happening is that when you see through the water, you see an image. The arrows had been turned magically, we don't know why it is turned to the left hand side. When we pull out the figure again, it is showing on the figure, it is showing that the arrows are pointing towards the right hand side, whereas again we put the figure where the arrows are pointing on the right behind the glass filled water. You will see that the arrow again points surprisingly to the left hand side. So why this happens is that it is due to refraction. Okay, it is due to refraction. Refraction in simple terms is bending of the waves when passing from one medium to another medium. In a sense, if you see this example itself, okay, the light rays pass from air, and when it passes through the water, it undergoes a process. The light rays undergoes a process called refraction. Refraction is the bending of waves when passing through one medium to another medium. Okay, we'll take a simple example to understand it further. If you see a hunter, see this hunter is standing on the ground and he is trying to shoot. There is only one image in the water. Which image should he shoot? At the top image or the bottom? Okay, so the top image is the virtual image. You should always understand when the light passes from which medium? When it passes from our air is a rarer medium. When the light goes into the denser medium compared to the air which is outside is a rarer medium, okay, air. And when the light rays passes to a denser medium, that is water, the light bends towards the normal. Why it bends towards the normal is that you can see the figure out there. The light rays becomes slower. So when it passes from medium 1 to medium 2, you can see there is a perpendicular line, that is a normal, that is an imaginary normal we draw for our understanding purpose. Okay, in reality there is nothing called normal. This is just to make us understand. When light rays passes from medium 1 to medium 2, it bends towards the normal. Okay, why? Because it passes from a rarer medium to a denser medium. And when it you can see the image below, refraction is caused by the change in the speed. Slower, in a sense, when the light rays are so slower, means it is passing through from rarer to a denser medium. And when it is away from the normal, means it is, for example, when light rays are passing from water, which is a denser medium, to a rarer medium, then it is the rays are bending away from the normal. That is the reason why the hunter has to shoot below the image, not on the image. Once he sees the image on the top of the water, he has to shoot below the image, or else he won't be able to kill the fish. Okay, because the light rays which is passing from a rarer medium outside, when it goes into the water, it becomes slower. Light rays become slower. Okay, because water is a denser medium, so the refracted ray bends towards the normal in that case. Now if we suppose that image of the fish, the refracted ray passes from the fish to the water surface, and when it reaches the surface, it is passing through a denser medium, and now it goes to the rarer medium. So it goes to the eyes of the hits the eyes of the hunter. So the refracted ray bends away from the normal. That is why the image is seen on the top of the water. Okay, that is the primary reason why the hunter sees the image as a virtual image, and actual image is right below. We will discuss further why the actual image is down. Let us take the example of the same thing. Same pencil is dipped in a glass of water. From the water you can see on the water level the pencil is acting as if it is bent. Okay, so this is an activity for you. Just as you seen earlier, where will be the original image formed in the water? The pencil is showing two images. Is the top image a virtual image, or the bottom image is a real image? So you have to confirm that. Is the top a virtual image and the bottom is a real image, as we see in the case of the fish, or is it vice versa? So you have to draw it on a paper and see for yourself, then you will understand it. So this is the first example of refraction, wherein take a beaker in which you have pour a glass of water. When you dip a pencil inside the image, it shows it as bent. So there are two images formed in the water. One is the real image and second is the virtual image. So my question to you, the image which is shown on top right below the level of water, is it a real image or a virtual image? And the image which is shown at the bottom of the bottom right below it, is it a real image or a virtual image? Okay, and now we will be understanding it further, why the hunter from outside the water has to shoot. You can see the fish. Okay, the fish is actually below the virtual image. So on top it is always the virtual image, and the bottom is the real image. Similarly, pencil also, you have to go to the example of the pencil which is dipped in the glass of water, wherein the image which is on top, okay, it is a virtual image, and which is right below it is a real image. Okay, so this is that I wanted to clarify more on that. That is why we took this example of pencil and a glass of water, and again we compared with that of a fish, so that you can correlate it better, because you had seen an example of fish wherein an hunter is shooting his arrow from outside. So now I think it is crystal clear for you how due to refraction the ray of light bends. If it travels from a rarer medium to denser medium, it has to bend towards the normal. And the opposite happens when the ray of light is refracted from the water, which is a denser medium, and goes into the air, which is a rarer medium. So it has to bend away from the normal. That's it. So this is about refraction. Now we will be taking a second example wherein a person has gone in front of a swimming pool and he is seeing the level of water from outside. The height of the water appears to him as shallow, but it is actually 10 feet deep. It looks as if it is shallow from outside. Actual depth is 10 feet. For him, he is standing outside and perceiving that this is not 10 feet. He might be thinking, due to that virtual image which is shown in the figure, the apparent depth, it is shown, you will visualize if you are standing outside the water as less than 10 feet if you see from outside. That is why when you stand outside of the water, you have to be very careful. You can't gauge the depth of the sea water, okay, from standing from outside, because the water always, as we have seen, the refracted ray shows us two images. One is the actual image, it doesn't show us, it will show you the apparent or the virtual image. So the apparent depth is always less and actual image is always more. Okay, this is the second example. Now we'll go to the third example of refraction. This is the third and the last final example of reflection. Okay, here what we see a deep water. Okay, a deep water in a sense, this is very deep. It is in the ocean itself, in the sea, and you can see shallow water also. So the light, this is a perfect example to make you understand how the light travels in deep water and shallow water. Okay. Now refraction is a change in speed of the wave when the medium changes. Okay, the refraction of light is the change in the speed of the wave when the medium changes. Here there are two mediums, one is air and one is water, sea water. Now the light from the air strikes on the dense water. We'll take the case of the dense water. The light travels from less dense medium, which is air, and goes into the sea water, which is more dense. Okay, so less dense we had called it earlier rarer, and more dense medium, that is sea water, it is we can consider it as denser medium. More dense or denser medium is one and the same. Okay, so in deep water what is happening is that you can see the waves, the speed of the wave is directly proportional to lambda. So what is speed of the wave and what is lambda? You can see the speed of the wave is equal to the frequency into the wavelength. Wavelength is represented as lambda. Frequency of the waves remains constant, whereas the speed of the wave, you can see in the deep water, the speed of the wave is spread out, you can see, and in shallow water it is, you can see it is much more together. Okay, so you can see what is the wave is much more slower in shallow water, and the wave, while it moves faster in deep water. Deep water, why it is faster? Because the frequency and lambda is greater. That is why the waves move faster in deep water, and the waves move slower. Why? Because in shallow water is that the frequency is less and the lambda is also less. So it is directly proportional. The frequency and lambda is directly proportional. So if frequency decreases, so lambda will automatically decrease. So that is the reason why waves in the shallow water move slower, and comparatively to the waves in deep water, which has higher frequency and higher wavelength lambda. So if you can see that, visualize that V is equal to F lambda. So V is on the greater side and lambda is also on the greater side. That is the primary reason why wave move faster in deep water. So here also you can see this is also an example of a refraction. The speed changes, the speed of the wave also changes, and light, once it falls on this surface, this kind of surface also, refraction, due to refraction, the speed of the light when it falls in shallow water, okay, and when it falls on the deep water also, the same case happens. Light enters from a rarer medium, which is air, into the sea water, so it has to bend towards the normal. Okay, so these three examples of refraction, and that's it. We had spoken about reflection, refraction, and diffraction. Okay, so thank you for watching. You have a great day, and hope you have understood all the concepts. This was made possible with the help of pictures, so that you can visualize much more and you can study much more. Thank you. Thanks a lot.